All right, so we're going to do one more lesson of graphing, and we're going to graph things called rational functions. So when I talk about a rational number or a ratio, what am I talking about? So for ratio or rational number, if I talked about something being a rational number, yeah, something over something, or just a fraction, right? Okay, so if you're going to basically graph a fraction. Now, more specifically, we're going to graph something like this. Okay? And let me go to this so I can go to Desmos. And let me bring it up. So I'm going to graph that first. We'll talk about a couple things in the notes. Oops. This is what I want to click on. Okay, just making sure it's showing up. Because I've done that before, thinking that was going to be on there, but it never was. So, all right, so let's graph that, and let's see what it looks like. We've probably seen it already. I don't think you actually had to graph it from scratch before, but now we're going to graph it from scratch. But I want to look at it first, and then we'll look at it to graph it by hand. But let's just see what it looks like. So it's 1 over x, right? So it's 1 over x. There it is, right there. And let's push that over. And let's zoom out just a tad. So that's what our 1 over x function looks like. There's 2 parts to it. All right, one part goes like this, and the other part goes like this. And we're going to do stuff to it, just like we've done before. You know, if we added something to it, it would make it go up. If we did something to the x part of it, it would make it go left and right. Okay, if we made it negative, it would switch the direction that it's going. All that stuff that we did before, we're kind of going to do again. Okay, but this is a little bit more complicated, I guess, to graph than what we've done before. There's one word we're going to talk about here in a second, and I took all these notes and found the definitions and all these kind of things, but the more I thought about it, the more I'm just going to talk about it, show you what it looks like, and then we'll work on it some more. I'm not going to get super crazy down and dirty on this stuff, okay? I just want to give you a general explanation of it, and I think that's really all you need. Talking to Mr. Rao kind of helped me out with that too, because some of the other stuff I was teaching, I was just trying to get way too tedious. I was way too tedious on it. And he's like, you don't have to worry about saying that. Just explain this and this. I'm like, okay, that's a lot easier. So I figure if he was okay with that, then I'm okay with this. One thing we want to do is take a look at a thing called an asymptote. It's not the first time you've heard that. Do you remember that word? Asymptote. I'm not going to write it down just yet. I think you can write on this thing. If I did this, I think you can just start writing, can you? Yeah. Okay, so let's write it. So asymptote. It's got a P in there, T-O-T-E. All right, so there you go. So there's a word. And what the asymptote is, it's where the graph is undefined, okay, where the graph is not going to cross, okay? It's probably the easiest way to say it, I guess. But technically the definition says it's the line that the 2 branches of the graph approaches, okay? It approaches it, but it's never going to touch it, or it's never going to go across it. Because if it crossed it, then it would be touching it, all right? But where is the asymptote here? There's 2 asymptotes. There's one vertical one, and there's a horizontal one. So look at these 2 graphs. If I zoom out a little bit, you can kind of see what's going on, right? To see how this gets closer and closer and closer to what? 0 where? Give me x equals y equals something like that. Is it x equals 0? Why is it y equals 0? Because y equals 0 is what kind of a line? It's a horizontal line. X equals 0 is a vertical line. Very good. Okay. So right where the mouse is going right there, it's approaching what? Okay. Again, it's not just 0, but what? It's approaching this horizontal line, right? So what is a horizontal line? We just said it. Say it. Y equals 0. Right. Okay. Let's try it one more time. So this line right here, as it's going to infinity, okay, what is the graph approaching? The graph is approaching what? Y equals 0. Very good. Okay. So as we go up like this, what is it approaching? X equals 0. That's right. It's getting really, really close to that line. Look, I could keep, it almost looks like it touches right here, but if I zoom in, do you see that? It's not really touching it. And I could keep going forever and ever. It's never going to touch it, right? So keep that in mind. Let's go down here. There we go. All right, and what's going on here? As this goes to the left, as it approaches negative infinity, as x approaches negative infinity, then what does the graph approach? I'm sorry, the graph approach, I should say this. As x goes to negative infinity, what is this graph approaching? Y equals 0 again. And what about this? As this approaches really 0, right? As it approaches 0, what's going to happen? This goes to infinity, or negative infinity down here, right? So what are your two asymptotes? Your asymptotes would be y equals 0, right? See that green one right there? And what's the other? And that would be your horizontal asymptote. What's your vertical asymptote? X equals 0. And they made that purple. And there's your purple one right there. See it? So those are your two asymptotes. And those are really important to do when you're going to graph these things, is knowing which one is your asymptote. We'll do the very last thing we're going to do. We're going to do a little bit of algebra, I guess, or next to the last one, we'll do a little bit of algebra, and we'll find the asymptotes. What's that? Yeah, the horizontal asymptote would be y equals 0. Because remember, y equals 0 is a horizontal line. X equals 0 is a vertical line. Now, on these particular ones, this is called the parent graph. Okay, it's like the one graph that they all look like. We could mess around with this. Watch. What could I do to that y equals 1 over x? Y equals, watch, I'm going to go 1 over x. What if I wanted to shift that thing like up a little bit? Okay, let's do that. Let's put a +2. And we got to zoom out to see it. See that red one, that black one right there? They're basically the same function, except that black one went up. So what's the horizontal asymptote on that black one? It's y equals 2. Right. Remember, the horizontal asymptote is always y equals something. And look, it gets really close to here. If I wanted to put that in there, let's put it in there. Y equals 2. So it's red. It's a little thicker right here. But that red one right there is your horizontal asymptote for that black curve. Okay, there's a lot of that stuff. There we go. That looks a little bit better. Okay, everybody see that? So it's not always y equals 0, x equals 0. Okay, the asymptotes could be shifted over. What if, let's just take this one. What if I wanted to move this to the right 3 places? Where's the -3? If I want to move it left and right, where am I going to do it to? I'm going to add or subtract it to the x. That's right. Okay, I'm going to do it to the x. So if what did I say? Move it to the right? Is that what I said? Okay, what if I want to move it to the right 3 places? What am I going to put in there? -3. And look at that. See that? Now, where's your vertical asymptote? Your horizontal stayed the same, right? Still approaches that, never reaches it. Still approaches that, never reaches it. What about the vertical one? Where's that going to be? At 3. That's right. Because look what happens. Because it can never reach 3, can never approach it, right? So if I put a 3 in for x, if I said x equals 3, what would happen here? 3 minus 3 would be what? 0. What's 1 over 0? It's undefined. That's right. It's undefined. Everybody see that? So that vertical line, okay, that's where that function is undefined. So if I wanted, let's put it in here. So where's the vertical asymptote then? X equals what? +3. And there it is. Everybody see that? So there's your horizontal asymptote. So here's your function right here. All right. So your horizontal asymptote is y equals 2. Everybody see that? All right. And then your vertical asymptote is x equals 3. And we got to figure out how to do that. The vertical asymptote was pretty easy to find. What do? We just set that denominator. Remember, that denominator cannot equal 0, right? So technically what I did, I just stuck a 3 in for the x, but really I took that x minus 3 and I made it so it can't equal 0. So x minus 3 cannot equal 0. Solve for x. X cannot equal what? 3, all right? So if you look on this, nowhere on here is x going to be a 3 for that graph, for that black graph right there. You'll never have a 3 for the x because it can never touch it. Make sense? So how do we find the vertical asymptote? We take the denominator and we make it so that it cannot equal 0, and then we find out what x can the denominator not be. All right? And what can the denominator not be? It can't be a 3. All right? And that's my vertical asymptote. X equals 3 right there. So that's kind of interesting, isn't it? All right. So knowing your horizontal asymptote, your vertical asymptote, where these go. Now, we could do some other crazy things to this. We could make this. Let's put the x. We could maybe put I'll tell you what, let's do this. Let's highlight that whole thing, copy it. I think I can move these, put them right next to each other. But watch what I'm going to do to this one. I'm going to put, a 2 in front of it. Watch what happens to this one. Boom. Now, wonder, I should do this. Let's do this. Let's put this in parentheses. Yeah, that's what I wanted it to do. That works better. So look at that green one and look at the black one. See the black one, and let's say let's make it so they're just ones on the bottom. All right, so each one of those blocks is a 1. Is that all right? So if I go over 1 and up 1, see that's my parent one, that black one. So if I go over 1, up 1, because y equals 1 over x, right? So, I think we're going to write that down. We'll talk about that in a little bit. But see what that does? See what the 2 on the bottom does? It makes it like a little skinnier or closer. It condenses it, I guess. Okay, and so what do you think it's going to do? Watch this. Let me highlight this whole thing again, and let's do something else to it. Let's take that out of it and put a number up here, like a 4. All right, and see what that does to it. Let's put this underneath of it so I can see the difference. So let's get rid of the green one. Now let's compare the purple one to the black one. Again, the black one is the parent function. That's like your normal one, I guess, if you want to call it that. But do you see what it does when you multiply it by a number? When you multiply it by a number, it goes further away from, I don't know what you really call that. It seems like they should call that number right there something, where the 2 asymptotes come together. Right, but you see how it's further away? It's spread out more, right? So if it's on top, what's it do? It spreads it out more. It expands it a little bit more, okay? If it was on the bottom, like this one, see what it did? See, the other one was up here. Put them both on there now. See, now that's a 4. I'll tell you what, let's just do a 2 just to show you the difference. There you go. All right? So this one right here, that purple one, is when you're multiplying it by 2. And this one right here, the green one, is basically when you're dividing it by 2, right? Because we put it on the bottom. Does that make sense? See the difference that it makes? All right? It keeps the same shape, basically. Basically, it keeps the same exact shape, except one is a lot of a tighter of a curve, and one is a lot, more of a slopey or less of a slopey kind of a curve. Make sense? This is your normal one, right? Your parent one. Okay, this is if you're dividing. This is if you're multiplying. We got it? All right. So that's basically the kind of stuff that they're going to ask you to do with these things is that stuff right there. All right, I think that's pretty good. Let's go back to writing. All right, so let's turn that back on. There we go. And I think, oops, I thought we were good. Yes, we are. Good. All right. So you kind of know what that's going to do. Oh, we forgot to do a negative, didn't we? What do you think the negative's going to do? So look, and I'm not going to be really particular about these. We're basically doing some relatively rough sketches on these, okay? We're not being really, really particular on this. So if I was just going to graph y equals 1 over x, what's that going to look like? Well, it's going to start up here like this and come down here like that. When I say rough, that's what it means, okay? Then, hey.
What are you doing? I'm going to put my ears on here for a second. Better look for me, right? How's it going, Mr. Hamrick?
I'm doing great. This is it.
That's it? That's what you get?
I told the teacher when I walked in, I said, they don't want to see what I wear to bed because I'd probably get fired if I don't have any pajamas.
It's working hard to stay warm. It's really cold out there. Okay? Give you guys an extra hour today. Mr. Hamrick, thank you for all that you do.
Sure thing.
Guys have a good day.
Thank you.
Thank you.
All right, so this is what your basic graph looks like, because you're gonna have to do these by hand. Everybody watching? You can't rely on Desmos. Now, if you're doing homework and stuff, you can do it and then put it on Desmos and see if it looks like it's supposed to and all that kind of stuff. But on a quiz or a test, you're gonna have to do this by hand, and on some of these, I will not let you use the calculator to do these, okay, or the Desmos app. Everybody with me? All right, because I think you should be able to know how to do some of these things. What if I said this? Let's do it in blue. What if I said, I don't know, g of x is equal to negative 1 over x? What do you think that's going to do? Yeah, because if you look at this, you don't have to do this all the time, but sometimes this is pretty helpful. Okay, think of the little chart, your little XY chart thing. All right, so if you put a 0 in there for x, what's that going to give you? If you put a 0 in for x, it's going to be undefined, right? So I'm not going to put any zeros in there. I could put a -1 and a +1, though, couldn't I? So what if I put a -1 in for this first one, this red one right here that's showing up? If I put a -1, what do I get? So if I put -1 in for x, what should I get? Yes, if I put a -1 in for x, I should get a -1 in for y. Do you see that? Hits right on there. If I put a +1 in for x, I should get, boom, hits right there, like that. What if I put a 2 in for that? What if I put a +2 in for this first one right here? Put a 2. See, I'm going down. So I go a half. Now, I didn't draw this very accurately, but this would be at a half. Okay? What if I put a half in? See how it climbs so quickly? What if I put a half in? What's it going to give me here? It's going to give me a 2. Yes? You with me on that? All right. So what if I did that to this blue one right there? So what if I put in a +1 in for this blue one? If I put in a +1, what am I going to get? I'm going to get a -1, right? So my curve's going to be down in here. What if I put a -1 in for this right here? If I put a -1 in, I'm going to get what? A positive. So my graph's going to be here. So what's that going to look like? It's going to look like this. and like this. All right, once you know the parent graph, doing the rest of it should be pretty easy. See, I wasn't like super picky that, if I put in a 4, I'm exactly at negative 1/4, okay? I don't have to be that accurate, okay? I just have to have the basic shape of it, all right? That's all I'm looking for. Does that make any sense? All right, so that's the kind of stuff that you're going to be doing. So this would be a negative 1, right? The blue one would be negative. The red one would be positive. And the stuff that you saw in Desmos earlier, right? We can move the x asymptote over the y asymptote and all that kind of stuff depending on what we got here. All right, I think that's good enough for graphing it. Let's do, this is example 1 in the book. So let's do this, and we're going to do it really without any graphing. And I want to show you how to do this. So this is example 1. And it says, determine the asymptotes for this graph. So I'll just say find. Determine them, find out what they are. Okay, asymptotes. Now, they could say find the x asymptote and the y asymptote, because there is another one as a vertical one. We're not going to do that today. But find the asymptotes, which means the horizontal and the vertical one for this particular graph. All right, this looks a little bit scary. But all we're doing is finding the asymptotes, and I'm going to show you how to do that. Now, let's do the x asymptote first. Remember we talked about that, the x asymptote? So what does that mean, the x asymptote? Or I'm sorry, not x. What am I saying? Vertical. Okay. What about the vertical asymptote? That's the x equals. That's why I put x in there. I wasn't thinking. What do we look here? What determines the x asymptote? The denominator, right? Okay. So what can this not be? It can't be 2, right? So technically I would do this. I would say x minus 2 cannot equal to 0. Agreed? And then just add 2 to both sides. That means x cannot equal 2. Because sometimes this may be a lot more complicated than it is right now, right? It might be 3x minus 2, or it could be something crazy. But that's what you would do. You would set the denominator so that it cannot be 0, so x cannot be 2. That means if x can't be 2, that's my vertical asymptote. Okay, so my vertical asymptote is the equation of the line x equals 2. You're like, well, why did you put it can't be 2 here, and then you put it is 2? Well, this represents the actual equation of the line. If it's a vertical line, it's x equals whatever number it goes through on the x-axis, okay? So if you just wanted to put equals 0 and then put x equals 2 and then put it there, it's fine. But technically, that's what's really going on. Remember, x cannot be 2. So what line is it? It's the x equals 2 line. That's the line that our graph can't cross, right? Can't touch it, can't cross it, right? So that's the vertical asymptote. Now, this one requires a little bit of math. Here's the horizontal asymptote. Okay? And what we're going to do is we are going to take that, instead of writing f of x, we're going to write it y equals, because we're going to do a little algebra. It's a lot easier working with algebra with a y than it is an f of x. Okay? So we're going to write y equals 3x minus 1 over x minus 2. So what we're going to do is we're going to take this and we're going to solve for y. I'm sorry, I lied. Y's already there. We're going to solve for x. Okay, so we're going to solve for x. So we got to do a little bit of math to solve for x here. So what do you think? You got an x here and an x here. So what do you think you're going to do to get x by itself? Some algebra stuff. Well, I don't like the fraction, do you? So let's take this and let's put it over here on top. So what am I going to do? I'm going to multiply both sides by x minus 2. Everybody see that? So I got x minus 2 times, let's do it like this. We're going to multiply both sides by x minus 2. Now what happens when I multiply this side by x minus 2? cancels out, doesn't it? Are you watching? See what I did? Watch. I multiplied this by x minus 2, and I multiplied this by x minus 2. This x minus 2 cancels, and now what do? I would distribute, wouldn't you? Just to try to, you'll see it works. You could write yx, but I'm going to write xy minus 2y equals 3x minus 1. Again, what are we trying to solve for? We're trying to solve for what? Trying to solve for x. So that means I want to get x on the same side, correct? So add 1. Well, I already got an x over here. Let's take this x and move it over to the left. See that? All right. There's a couple ways you could approach this. This is how I did it. So subtract a 3x from both sides, right? That got rid of it here, didn't it? Moved it over here. And might as well just take this minus 2y, put it on the other side, right? Since we're trying to get everything on the left-hand side, all the x's on the left-hand side. Is that right? So add a 2y to both sides. So what do I get? 2y minus 1. You could have done that in the next step. I just saw it. So let's do it now. Again, we're trying to solve for x. I got an x here and an x here. We haven't done this in here. I don't know if we've ever done this in here, have we? Should have done a ton of this in Algebra 2. What do I do to get just one x there? Was it? Okay, but what do I do? How do I get that? Give me a math word. Again, I don't know if we've really even talked about it in here. We're going to factor out an x. Do you remember this? Okay, so we're going to factor out an x. Got an x in common, so I'm going to factor out the common x. So factor out the x. What do I have left now? Y minus what? 3. Good. Is this coming back to you? We're going to be doing a lot more of this stuff in the next chapter. We're going to be doing a ton of this stuff. All right, again, what are we trying to do? We're trying to get x by itself, aren't we? So now we are kind of ready to do that. How do I get x by itself here? Divide by y minus 3. So let's do it. X equals 2y minus 1 over what? Y minus 3. Okay, now we got x by itself. That was our first thing to do. Now we can look at it, okay, and say, what can y not be this time? Because now we're doing horizontal asymptote, right? So what can y not be? That's right. So that means my horizontal asymptote, wish there was a shorter way to write that, but I'll just write it like this. Horizontal asymptote is what? Y equals 3. All right? So if we were going to graph this thing, let's do this in a different color. If we're going to graph this thing, let's just do the asymptotes right now. The horizontal asymptote is y equals 3. So 1, 2, 3. So it's going to be dot, dot, dot. And we usually, on paper, we put dots for the asymptotes, okay? Like on that graphing program, Desmos, it's a solid line, but when we draw it by hand, we usually use dotted lines to do that. So that's our horizontal asymptote. And what's our vertical asymptote? What was that? X equals 2, so 1, 2, and then like this. All right, and that's basically kind of like our new x and y axis, right? And that's what it's going to look like. So what do you think you would probably do? Just a rough graph to this. Probably look like this and something like that. All right? And that's what you would do. So really, the key to this is finding the horizontal and vertical asymptotes. Once you find those, the basic shape of the graphs, are pretty much the same. All right? And that's really all you'd have to do with something like that. Does it make sense? I mean, think about it. What did this do Nah, forget what I was going to say about that. Yeah, it's good enough. All right, they give you some examples. Again, I'm just going to do a really rough sketch with these things. Let's put a little X and Y axis here. Group that and copy that. Okay. All right, so here we go. Here's part A. It says they put all these different letters, G of X, H of X, and all that, just to so they're not all just F of X. But what would this do? What does that tell you right off the bat that you're going to do? What does this tell you to do? You know what 1 over X looks like, right? Right? It looks like whoosh and whoosh right there. Okay? What's that going to do? It's going to go 5 to the left. What's another way you would know that it's 5 to the left? What's your vertical asymptote going to be? It's not 5, because 5 plus 5 is 10. It'd be negative 5, right? Because negative 5 plus 5 is 0, right? So guess where it's going to hit? 1, 2, 3, 4, 5. So that is your vertical asymptote. Everybody with me on that? And if you wanted, watch, let's make this y equals 1 over x plus 5. Let's solve for x. So that means I could put what? X plus 5 over here, divide by a y, so it's 1 over y. So it's 1 over y minus 5. What can y not equal? 0. So what's our horizontal asymptote? It's just y equals 0, right? So it's just the x-axis, isn't it? All right. So this and this is what we have. This isn't a negative. So what's this basically going to look like? Again, just real rough. What's it going to look like? It's going to look like this, and then it's going to look like that. And that's how you graph it by hand. Okay, you just got to know a couple key things about it. You don't have to know where every single point is perfectly. You just got to know the basic shape of it, all right, where the x and y asymptotes are, and you should be pretty good to go. Make sense? Even if it had like a 2 in front of it. Remember what that did? Brings it in, or actually brings it out a little bit wider. Okay, not even care about how wide you go out. You could still, like this graph and the original one that I gave you, if you graph it like that by hand, they're both fine. I mean, technically, are they the same? Not really, but as far as we're concerned, that's good enough. All right? I'm not going to be really, really picky on this. What's that? This moves it left and right because it does it to the x, right? Because it's doing it to that x. It's not just a plus 5. Like if this was y equals 1 over x and then a plus 5, then it would take that whole thing, it would take this and move it up here, and then your y asymptote is y equals 5. Okay? See the difference? All right. All right, let's do another one. All right. Let's see. I use h of x this time. Equals negative 1 over 2x. Remember, this is dividing it, so it's going to actually, let's see, it tightens it up, right? If it's over 2. But again, I don't really even care about that 2 as when I'm graphing this by hand. Okay, I really care about the negative. All right? So remember what it does? And your positive would go here. Where was the negative go? Now, did we shift it anywhere? What about the x and y or the horizontal and vertical asymptotes? No, it's not shifted anywhere. So really, the only thing this does is just makes it negative, right? So it looks like this. I didn't draw that very pretty. And then, it's terrible, but you get the idea. Something like that. That's pretty ugly. You probably do it better on paper than I can on this thing right here. Okay? Getting the idea? All right. Really, the only thing you had to worry about was that being negative. All right. Let's do another one. Let's see. This time it's k of x is equal to 4 over x minus 3. So what do we care about right here? That minus 3. What does that mean it does? Moves it to the right 3 places. Okay? And so my vertical asymptote, again, would be a 3, wouldn't it? Right? Because 3 minus 3 makes it a 0, so that's my vertical asymptote. Right? So that's what it looks like. Now, it does like shrink it a little bit with that 4 on top, but again, I'm not really caring about that, so really all you got to do, all you got to do is that and that. Again, this is really sloppy, but you can be a little bit cleaner with it. Does that make sense? That's all that thing does. Just moves it to the right. It's just a regular old inverse function. Just moves it to the right 3 places. And again, you don't have to be super, super picky about it. I got one more, I think. Yep, one more. I don't know. I don't understand how that stuff goes on over there. Just don't get it. It doesn't seem to bother him. Just does not seem to bother him. I don't know. All right. This is m of x. How do you think I would act if my classes were doing that? You think I'd be nice and calm? And you've had me long enough, haven't you? Yeah, I don't think I'd be that calm. I'd be flipping out. All right, what's going on here? That's 6. I'm not really concerned about that. What am I really concerned about? There's 3 things I'm really concerned about here. What is that? The minus, right? So it's going to flip it and go like this. Yeah, it's going to go like this and like this, right? In the second and the fourth. What's this plus 2 going to do to it? Yep, that's going to shift it where? Left. Okay, I was hoping you said that. I thought you said right at first. So it shifts it to the left 2 places. So that's going to be my vertical asymptote. Am I back to this? Yeah, okay. I was just double checking to make sure. All right, and then what's this minus 4 going to do? It actually shifts it down 4 places. So really, here's my horizontal asymptote, and there's the vertical asymptote. And now, all I got to do is just do an inverse of this. So what's the inverse look like? Looks like it's down in here, and it's up like this. And there it is. So it's a sketch, okay? It's not a full-blown graph. We sketched a graph, okay? It's a very non-detailed graph, but it's the basic idea of what that looks like. And you could always check on Desmos against it just to see if it kind of looks the same. Don't do this, though. Don't just put it on Desmos, look at it, and say, oh, I think I can draw that, woof, woof, and do your little swooshes and stuff. Because on a quiz, I might say, okay, no phone on this, no Desmos, no calculator, anything. All right? And you're going to have to graph this. So make sure that you can do this by hand. That's not too hard, is it?
When the bell rings for the following
Okay.
to the office, Emma Blickenstaff, Lizzie Pasquale, Aiden Markowitz,
All right, let's see. What did I give you?
Josiah Barber, Jacob Ulrich. Thank you.
So 14 to 23 is what you're doing. So this is section 3-7, and you're doing 14 to 23. That's all I'm giving you. I put A on there. I'm not really sure why I put A because this is the only one we're doing. All right, so we're only doing these. Section 3.7. It's page 186. I don't know why I put A. I must have been planning on doing a part B, but I'm not. All right, 14 to 23. Everybody good?